The Teton Range is a mountain range of the Rocky Mountains in North America. A north-south range, it is mostly on Wyoming's eastern side of the Idaho state line. It is south of Yellowstone National Park, and most of the east slope of the range is Grand Teton National Park. Early French voyagers used the name Les Trois Tétons, the three breasts. It is likely that the Shoshone people once called the whole range Tiwanaut, meaning many pinnacles. The principal summits of the Central Massif, sometimes referred to as the Cathedral Group, are Grand Teton, which peaks at 13,770 feet, Mount Owen, which peaks at 12,928 feet, Tiwanaut, which peaks at 12,325 feet, Middle Teton at 12,804 feet, and South Teton at 12,514 feet. Between 6 and 9 million years ago, stretching and thinning of the Earth's crust caused movement along the Teton Fault. The west block along the fault line rose to form the Teton Range, creating the youngest range of the Rocky Mountains. The fault's east block fell to form the valley called Jackson Hole. The geological process that led to the current composition of the oldest rocks in the Teton Range began about 2.5 billion years ago. At that time, sand and volcanic debris settled into an ancient ocean. Additional sediment was deposited for millions of years, and eventually heat and pressure metamorphosed the sediment into gneiss. Subsequently, magma was forced up through the cracks in the gneiss to form granite, anywhere from inches to hundreds of feet thick. Other intrusive igneous rocks are noticeable as the black dikes of diabase visible on the southwest face of Mount Morin and on the Grand Teton. Starting during the Cambrian period, deep deposits of sedimentary rock were deposited in shallow seas over the metamorphic basement rocks. Erosion and uplift have exposed the metamorphic and intrusive igneous rocks now visible on the east slope of the range and in the Cathedral Group, and the Paleozoic and Cenozoic sedimentary rocks on the west slope. 2.1 million years ago, the Huckleberry Ridge Tuff was also deposited along the west slope of the north part of the range. Mesozoic deposition changed from primarily marine to a mix of marine, transitional, and continental that varied over time as crustal conditions altered the region. By the close of this era, 10,000 to 15,000 feet of sediment had accumulated in 15 recognized formations. The most extensive non-marine formations were deposited in the Cretaceous period, when the eastern part of the Cretaceous Seaway, which was a warm shallow sea that periodically divided North America in that period, as you can see in the photo. This seaway covered the region. Their sediment came from rock eroded from a mountain chain east of the seaway, interbedded with ash from volcanoes west of the seaway and the Sierran Arc, which was a long volcanic island chain. This ash eventually became bentonite, a clay which expands in water, which leads to the many landslides in the Grand Teton National Park today. Regional uplift in the latest Cretaceous time caused the seaway to retreat and transformed the Grand Teton area into a low-lying coastal plain that was frequented by dinosaurs. A fossilized Triceratops was found just east of the park near Togwotee Pass recently. Coal beds were eventually created from the swamps and bogs left behind after the last stand of the seaway had retreated. Coal outcrops can be found near abandoned mines in and outside of the eastern margin of the park. Also, outcrops of older Mesozoic aged formations can be found north, east, and south of the park. Deposition resumed again in the Cambrian period and continued through the Paleozoic era, creating 9 major formations, which together are 4,000 feet thick. This unit was laid down in a shallow sea and later became a discontinuous mix of dolomite, limestone, sandstones, and shales. The layers of this unit are relatively underformed for their age, even though periodic upwarp exposed them to erosion, creating unconformities. Fossilized brachiopods, bryozans, corals, and trilobites are found in the carbonate rock layers, with the best examples found outside the park in the Alaska Basin. The most complete examples of this unit are found to the west, north, and south of park borders. The Grand Teton Formation doesn't really pose a threat to our human day-to-day lives, but just to the north, the Yellowstone caldera does. According to Science World Report, the eruption of the volcano at Yellowstone poses a threat to the entirety of the United States. It could wipe out half of the U.S., and the U.S. Geological Survey has stated that if the supervolcano does erupt, it will affect the food and water quality for the entirety of North America. There will be massive respiratory problems because of the huge quantity of ashes it would also most likely emit. This will also cause 10 years of uninhabitable devastation, particularly to the areas surrounding Yellowstone Park. So, the Teton Range would be greatly affected, and the entire area surrounding it would be completely uninhabitable. The Grand Teton region is both an outdoorsman and sportsman's paradise. With so many geological features, as well as rich soils to sustain an abundance of wildlife, the Grand Teton mountain range truly is a jewel of the Rockies.